Let me know if you're not able to see PowerPoint slide behind me. You should be seeing differential rules and derivatives of inverse trigonometry. Okay, now today we learn something new, which is the focus of this module. We will look at inverse trigonometry function. For your convenience, you don't need to memorize all these things, but you need to know where all this information available to you. So for example, what is inverse trigonometry? Means before this, I already do revision for you. I already do revision how to do trigonometry, differentiation and integration. So this one, we will do inverse trigonometry. What I mean by inverse, you'll see minus 1, minus 1, minus 1 beside the trigonometry relationship. Okay, minus 1, minus 1 being inverse, 1 over sine x, 1 over cos x, 1 over tan x. It means inverse. Okay, so if you see the question asks you to solve inverse sine x, you use the first equation. If you see the question have sec inverse x, then you use this equation. Okay, so these are the 6 popular relationship that will help you to score some marks. Okay, all right. Any question on these 6? Any question? Should be very direct, huh? Okay, let's see. Straight away go to example. Now, example 14, it asks you to differentiate y equal to 1 over sine minus 1x. So 1 over sine minus 1 over sine minus x is the inverse sine relationship. So just give you a convenient, I'll keep showing this table. However, in test or final exam, we won't provide this one, right? You have to keep this one somewhere in your notes, and during test or exam, you should know where to pull them out. So if you look at the question, and look at the table. Just now I show you 6 relationship. So this table give you sine, cos, tangent, cosec, sec, and cot. So you look at the question, you should be referring to the first one. Okay, so what I mean by differentiate y means f comma or y comma. So differentiate, you can write in the 3 format here. Far left, you can write dy dx, or if you want to calculate quickly, you can write y comma. Y comma means differentiate one time. Then after you write y comma, you write equal d over dx and the question. By writing this one, you score 1 point. All right, 1 mark for starting steps. Okay, any question on the first starting steps so far? Redmond, you okay?
Yes.
All right, so this is the first point to score. So in test or exam, don't say you don't know how to score marks in this module. Okay, in our module taught by me, it's very easy to score as long as you know there's a standard steps there. So this is a step I'm looking for if I ask you to differentiate an inverse trigonometry function. You write, if I ask you to differentiate one time, so y comma, and then you write d over dx and then copy the equation. The next, you just refer to table. So you rewrite, okay, you rewrite this one in exponential format. You know that 1 over something, you can put a bracket and power minus 1. So this one, you need to recall back your exponential equation. So 1 over something, you write in bracket, minus 1, it means the same thing. And you refer side by side. Now, you have the same pattern. This one and this one is the same pattern, only you need to add in the exponential in this one. How do you use this table? One, you get these steps. You know that you have a power rules, right? Before you learn this one, you know power rules. Means if you differentiate this one, is you will pull the end you pull this n to the front, and then this n you minus 1. So by using the power rules, the general equation power rules, you pull the minus 1 to the front, and you copy this one, and then this one you minus 1. You will get this equation. Okay, you'll get this equation. After that, since you are differentiating something with bracket and an x inside there, you need to continue to differentiate what is inside there. Okay, I repeat. This one, just a recall, I think you learned this one before already. When you differentiate something in the bracket with an x inside, let's say you differentiate the x and you have a bracket and you differentiate bracket inside the bracket, you're still seeing x inside there. Then you need to differentiate one more time after you use power rules. For example, this equation, you differentiate sine minus 1 x or inverse sine with the power minus 1. So what you do, you see this one as a normal equation. You pull 1 to the left and copy this one and this one minus 1. That's why you get the first term there. You get negative inverse sine x and power negative 2. When you solve trigonometry problem like this with the comma bracket inside there with the x, you need to remember to do one more time this one. D over dx sine minus 1x. Okay, repeat one more time. If you differentiate something with bracket inside got x1, 10 sine or something, you need to differentiate one more time. Okay, so you have already done for the first one. The next step is just to compare d over dx sine minus 1 with this table. So with this table, this one equal to this one. So you just copy this one, paste in your answer, substitute with this one with 1 over square root of 1 minus x squared. Any question from here to here to here? Shakir, you all right?
Okay, sir.
Okay, yeah. Then the rest is just rearrangement of equation. So your answer can be this one or this one. If this one come out in test or quiz, your answer can stop at here, or you can, if you're hardworking, you can change the minus 2 into a fraction number. Okay. Only I need to remind you is the negative sign. Okay, it's a negative sign. So this is the area where students forget every time, right? Even in your previous quiz, right? You will see that some of your answer you do not score full mark because of negative sign. Okay, so don't make that mistakes. And the mark question, the mark answer already in the Moodle. So if you can go and check in the Moodle for quiz 1. So any questions so far for example 14? Any question? Any steps that you are not clear? Nizam, you okay?
Yeah.
Okay. Let's look at another example. Example 15. He asks you to differentiate fx equal to x arctan and square root of x. So you see the sign cos arctan. This one is under trigonometry subsection. So he asks you to differentiate fx. So you know your first line in your answer, you should give me f comma x. You should know the first steps. He asks you to differentiate, you give me the differentiate general pattern. So this one, he asks you to differentiate. The first line you write. Also, this one is the information that you transfer into mathematics format. So this one, x arctan, arc tangent means tangent minus 1. Okay, arctang means tangent minus 1. So you convert the question arctang into mathematical model tangent minus 1. Okay, why sometimes you see arctang, why sometimes you see tangent minus 1? It is because for the clarification or for the clarity of publication, because sometimes when you do printing, it will be more confirmed. People understand if you write arctang, and if you're in your printing, printer sometimes the negative is very small, and maybe the one also very small. So sometimes during printing, the negative one will not be printed on the paper. So that's why some of the textbook they prefer to use arctang, and some good publisher they will use -1 above the 10. Okay, but anyway, if this one come up in test or exam, the first step is to copy the question, what asked by the question, and then he asks you to differentiate. So then pull out the table, and convert arctang into tangent -1. So you can compare side by side. This one, you have 6 relationship to refer to. So this one, tangent -1 is using this one. Okay, tangent minus x, you are referring to this equation. However, you need to, before you use this table, you have to convert the equation in differentiation pattern with a d over dx. Then you can use this table. This is the raw equation. So you need to answer the question. The question asks you to differentiate. So the next line, you should show us that you understand what is the common symbol for differentiation, or differentiate one time. Means f comma x bracket. Okay. Yeah, for this question, you have 2 function there. You have not function, but 2 entity there. You have x and tangent -1 square root of x. You can see this as a product. So trigonometry question, most of the time they are product, means you can see the f times g, right, is a 2 function, or you can see it as a u and v. So you can see this one as 2 equation inside, multiplication of 2 equation. So this one you expert already, This one you expert already. In fact, this one I think come out, not come out, but yeah, just give you hints. This important. This is important. Just give you some hint. So product rules, we already cover what is this already. So if you have 2 function, you need to differentiate. You can use this formula. Okay, f d dg g dx, or you can more familiar is uv. Then this one is u. This one is d dv or something. Okay. So you transform this one into differentiation. So you use the product rules. So f comma x equal to, you use this product rules. You know that your fx is x, gx is tangent -1 square root of x. So you just substitute based on product rules into this one. Okay, try to understand what we are trying to do here. First, you read the question and then try to see the pattern of the equation. This one, the pattern of the equation consists of 2. You can combine. It's a multiplication relationship. X multiplied by tangent -1. So that's why you can break this one into fx and gx. Okay, so you differentiate fgx. Sometimes the question will not be direct like the previous example. So this one is more nearer to your test 1 standard. So you will give a function, then they ask you to differentiate. So you need to see this one as 2 function like this one. So this is how you apply the product rules. Any question from here to here? Any question from here to here? Shakir, you all right? This one to this one. Shakir, are you okay? This one to this one. One more time, calling for Shakir. Do you have any question from this step to this step?
No, sir. Okay.
Okay. So this step onwards, you know that you need to simplify this one with this table. You see this one, right? Tangent x, tangent minus 1, square root x. You compare to this one. So what you do, you replace this one with square root of x into this equation. Right, this is just a reference table for you. So you compare side by side. You replace the necessary component. Here, the question you get square root of x. Here you got x, so you replace this one with square root x. You replace this one with square root x. This one you know how to do, right? Differentiate x, you get. Edmund, what do you get this one? Differentiate x, x. What do you get for this component?
1.
Okay, good. So you will get this one replaced with this one, like what I explained just now. You just replace the x, this component, into here. You refer to table. This one also follow this value. That's why you get this one. Then and again, show you the first component. Once you see the bracket one, when you differentiate the bracket one, after you differentiate, you need to go inside one more time to process the dx of this one. Okay, sorry, of this one. That's why the first component, although you refer to table already, but don't forget to go inside the bracket to differentiate. Go inside the bracket to find for the x to differentiate. Like in this case, you differentiate, you convert the information with table already. However, don't forget to do one more time differentiation. Go inside the bracket here, means you differentiate dx square root of x. Do you see the consistency of the steps? Although you're given table, just remind yourself, when you see inside bracket there's an x there, sine x or cos square root x or something. Remember, after you refer to table, there's a differentiation steps for the x component inside the bracket. That's why we add this one. Okay, just make a note in your personal notes there. Okay, usually student will forget these steps. Just give you hints. Your coming quiz will be one question on this one. So just don't forget this one in coming test. Okay, you miss this one means you get the wrong answer already. Okay, remember, when you have a bracket, something with the x inside there, remember to, after you refer to table, remember to insert this one in your answer. Then the next one is this one. You just copy the blue color, because blue color is a gx, it doesn't change it. And then this one equal 1, answer by Edmund just now. So the rest is just substitution, and you need to solve this one. Okay, Nizam, what do you get from this component? If you differentiate square root of x, what do you get? Nizam? Calling Nizam. Answer the question I asked you just now. Nizam, what do I ask you just now?
To differentiate the square root x, right? Center one.
what is this answer? When you differentiate this one, what do you get?
You get x half.
When you differentiate this one, you get x half. This is just a normal revision for differentiation. When you differentiate square root of x, what do you get? When you write this one in exponential, how do you write? Square root of x equal to x power what, Nizam?
X power 1 over 2. So basically it's 1 over 2 x to the power of 1 minus 1 over 2 is negative 3 over 2. Negative 1 over 2.
Okay.
1.
1 over 2 minus 1, what do you get? You differentiate. You differentiate is minus 1. Right?
Oh yeah, so negative 1 over 2, is it?
Yeah. That one is Shakil. Nizam, you understand or not? Or just now is Nizam answer. I think that one is Shakil, right, just now?
Yes, sir.
Okay. Nizam, do you understand what Shakil mentioned just now?
Yeah, sir.
So what is the answer for this one? Nizam, can you repeat? When you differentiate this component?
Negative half.
How you get negative half?
Because half minus 1 becomes negative half. That's what
So how do you differentiate square root of x?
Just now you told that the square root means like half x.
This one, x, okay, square root of x equal to x power 1 over 2, right?
Yeah.
Then you differentiate, you still get
Half
negative.
and half x, and then half x. The power of half minus 1 because you bring in front of it.
Okay, you'll get this one, the green color one. This one to this one. Okay. And the rest is this one. Then the rest is just simplification of equation. Okay. So this one, you square root, you get x. So this one become this one. Of course, you can change back or you can continue to use the minus there. And plus this one is times 1, so you get this one. So, and then you know that you can further simplify. You can take out the square root by, you know, the x, the blue color x, you can write as square root x times square root x, right? You can expand that one to cancel this one. Okay, x, the blue color x, you can write as square root x multiplied by square root x, you still get x. So the purpose of doing this one, because we want to cancel square root x with square root x. Okay. The purpose of writing single x with square root x times multiply x, because we want to cancel this one. Then this will be the perfect answer for this question. This will be the form, the simplest form for this question. So at the end, you write square root x divided by 2. Where is 2? 2 is from here. You push to the left. So 2 bracket 1 plus x plus this one. Any question for example 15? Edmund, you okay?
Yes, sir.
Okay. Yeah. So we already done how to use table to solve this one. Next, we look at hyperbolic function and derivative. So another new table. Now, just now is application of this table. So 6 equation, there's one table for you to refer. The next new table, we call it hyperbolic function. What I mean by hyperbolic? Beside the sec, you have a h there. Hyperbolic x. Cot with a h there. Sine with a h there. Cos with a h there. Tangent with a h means you are solving hyperbolic function. Don't confuse this table with the table just now. Just now is an inverse matrix. This one is a hyperbolic function. Okay, don't confuse the table. Yeah, just this one. So there will be a table for hyperbolic function. So just use the correct one, then you score some marks there. So for example, the first one, sine hyperbolic x equal to e power x minus e power negative x divided by 2. If you are having a cos hyperbolic x, you can write as e power x plus e power negative x. So don't confuse between the sine and cos. And then you know that tangent equal to sine divided by h, right? So if the question asks you to solve hyperbolic tangent, you use this one divided by this one. Meaning you calculate the sine first, then you calculate the cos. You can take the above, the answer from above, you put in here, the answer of above of second line here, put below. You simplify, you get tangent hyperbolic. Then this one, cosine hyperbolic x equal to 1 over sine hyperbolic. Sec hyperbolic equal to 1 over cos hyperbolic x. Cot hyperbolic equal to inverse of tangent hyperbolic. So that's why you see there's a flip of cos and sine compared to tangent. However, what is important for you to score marks in test and exam, remember there's a table for you to refer to. The rest is just substitution and simple either integration or differentiation. So this one is one table. Another table is this one. We call it hyperbolic identity. Also another 6 equation for you to simplify. So for example, if you see the first one, sine hyperbolic, this is for hyperbolic. Sine hyperbolic bracket negative x, you can write as negative sine hyperbolic x. If you're seeing sine cos minus sine square, both equal 1. Basically, this 6 equation is identical to trigonometry identities. But this one is in hyperbolics with the h. Okay, so these are all there to help you. Okay, so if this kind of question come out, right? If cos hyperbolic, of course, there will be one question in final exam. So be sure when you simplify your answer, this table is very helpful. You write out you look at your question, you write out the correct one, you will score 1 point for the correct equation. Again, if you write all the 6, you won't score any marks because I know you don't know which one is the correct one. Yeah, so do more exercise, then you'll know which one to use. Okay, so there are tables for you to refer to. Then, okay, I refresh one more times. There are so many information for you. First table, sine hyperbolic x. Identity, this table is to help you to simplify answer, where you can, especially you have a top and bottom, the fraction one. This one will help you to simplify the answer. Next one. If you need to do differentiation of sine hyperbolic, right? If you need to do differentiation of sine hyperbolic, then you use this table to convert the answer first. For example, the question asks you to differentiate sine hyperbolic x. What do? You use this table, convert to cos hyperbolic x. Then you use this table, cos hyperbolic x, right, equal to this one. Then you convert the answer of cos hyperbolic x equal to e power x plus e power negative x divided by 2. Yeah, so there are 3 tables. This one. Yeah, any question just now? Shakir, is it, or Nizam?
Sorry, sir.
Okay.
No question.
Okay. So we have 3 tables to help you. There's one more table. If your y, if you're seeing the question give you y equal to sine hyperbolic minus 1 mean inverse matrix of sine hyperbolic x, you can rewrite their form either left hand side to right hand side or right hand side to left hand side. Means you can switch their form. You can change, for example, the first one, you can change y equal to sine hyperbolic inverse negative 1 x. You can write them as sine hyperbolic y equal to x. You see the arrow, right? This arrow means irreversible, means either this form change to that form or that form change to that form. So you have sine, cos, tangent, the way you change it, right? So we don't have time to go through all the example using this one, but I want you to remember there's a reference table for you to look for answer. Okay. There's one more, this one and this one. Okay, so it takes time to identify. So you have a lot of table that you can refer to. So let's say you need to convert sine hyperbolic x in terms of ln. You use this table. Okay, if you need to put your answer in ln, then you use this table. If you need to put your answer in e, you use this table. Okay, there are different tables to refer to. It depends on the question. If the question asks you the answer in e power something, you use this table. Or you see in the question, you see e something, then you use this table. If you in the question you see ln, then you use this table. Okay, sine hyperbolic minus 1 or inverse sine hyperbolic equal to this one, cos equal to this one, tan equal to this one, and so on. Okay, yeah? So each table have their own purpose there, and it will help you to convert your answer to the correct one. For example, this one, when you need to convert to ln with the only x, okay, ln and x, you use this one. This one you need to convert between y and x, then you use this one. This one is for, you see d over dx, then you convert from this one to this one. Okay, this one, most of the time, when you need to use this one is from the question. Okay, the question asks you to differentiate something, then you use this one. Or when you come to half of your steps, you need to differentiate, especially the product just now, the product rules. You need to differentiate this one, then you use this table. Then this one also, in between your steps, you need to simplify steps, then you use this one. Again, this one, when you need to use this one is because in your answer, you need to balance both sides. Then you see there's an E there, and then you use this table. Okay. some time to familiar with which graph to use. We have no time to explain all, but okay, this is just extra. Then there's more table to refer to. So this one you can convert this one to this pattern, this pattern, this pattern, and so on. So there are lots of table for you to refer. Okay. So again, I don't expect you to memorize all the formula, but I will expect you to know which one is the correct one to refer to. And it's always quite direct. You look at the question, you know which one to look at already. Okay, quite direct. Okay. Let's look at the first example. Example 16. So example 16, it asks you to find differentiation of tangent hyperbolic -1, and inside there's one more bracket, sine x. So how do you start? You look at the table. There are 3 to 4 tables that you need to refer to. Pick the one that closest to this question. The closest one is this one, because you see d over dx. So you refer to the graph or table that give you d over dx. Then you do shopping inside the table. In this one, it's tan hyperbolic -1. So you go to d over dx is this one. Right, d over dx -1x equal to this one. So of course, inside there is sine x. Here in table is x. So what you do, you substitute this one inside here. Table is like a ruler. It just guide you through. It do not give you answer, but it give you with how do you do next steps. So you refer to this one and this one. Compare side by side. You know that x is sine x. So you replace sine x inside here. Okay. You copy the question. Differentiate hyperbolic tan inverse sine x equal to the question, the table. You copy the table. Substitute 1 over 1 minus x. Here is x, but in the question is sine x. So you just substitute sine x in here, then square. Remind yourself again, if you need to differentiate something and inside bracket there, you see an x there, you need to differentiate one more time. What is the x relationship? This one is the most popular mistakes students like to make. They always forget this one. When you have a bracket, every time I repeat, when you differentiate a bracket, remember to look inside the bracket if there's an x there. So 1 over this one, the first part refer to table. Next, this one is just a differentiation steps. When you have a bracket inside got x, you just differentiate one more time. Differentiate sine x. Any question from the question, these steps, this table and this table? You don't know how to arrive at these steps? Please let me know now. Nizami, okay?
Yeah, okay, sir.
Okay. Next, they also want table to convert this one. So basically, you don't need to memorize for this module. Already give you all the table. So differentiate sine x, you refer to one of the table in our slides earlier. Sine x, you differentiate, you get cos x. Then the rest, you see you can simplify or not. You know that 1 minus sine square of x, you can simplify to cos. Because why? This one is inside your Max 1 textbook. You need to download a trigonometry identity. I don't give you. You need to go and download or go and copy or photocopy the trigonometry relationship. Just now I give you one is the hyperbolic one. Okay, so if you're taking max 1, then I will give you, but you're taking max 2, so I assume you already know already. So cos square minus sine square equal to 1. So you simplify this equation, this relationship, to cos square x. Put a side note on your notes today, to-do list. Go and find the trigonometry identity chart and print it out, put it somewhere in your notes. It will be very useful when it comes to your quiz, test 1 and final exam, because the general equation will not be given. Okay, put a note in your personal alarm or personal notebook there. Your homework today, go and find the trigonometry identity chart. Okay, it's available in advanced mathematics textbook inside the appendix, or calculus textbook inside the appendix also. Okay, so you convert this one into cos square x. You know that you can simplify, you can cancel this one and only left out a cos x there. The final answer is 1 over cos x. Okay, you can leave your answer like this, or you can convert. You know that inverse of cos is sec. So 1 over cos is sec x. In test, you leave your answer here, also give you full mark, or you can further simplify to sec. Again, this is the very direct tutorial question. In final exam, you won't see this one. Final exam, I'll give you a scenario. You need to use what you learned in the example to solve. It's a long question. You need to extract step 1 do what, step 2 do what, and then one of the steps is this one. Okay, any question for example 16? Shakil, you okay?
Okay, sir.
All right. Next, we already done differentiation. Already cover differentiation. We'll go into the new section. Do you guys need rest? Do you guys need a short break? 10 minutes break? Edmund, do you need rest? Or you can go? You can continue.
Continue, sir.
Continue. Nizam, can you continue or you need break?
Can, sir.
Continue. Shakil, you okay?
Okay, sir.
Okay. So now we are looking at integration section already. Before this, we are all deal with differentiation. Now we are continue into integration. So don't confuse between differentiation and integration. Their procedure will be different. So recall, this table also give you in our lecture. These are all the fundamental steps when you do integration. So in exam or test, there's no reason say, oh, Dr. Ang, I forget, I don't know how to do. I don't expect you to memorize, but I already give you all the general equation here. You just need to refer to this one and then answer accordingly. If you see you need to differentiate, not differentiate, you need to integrate k, you'll get k, the first one. If you need to integrate a constant value without the limit, you will get kx plus c. Example, if you need to integrate sine x, what is the answer? Also on this table, integrate sine x dx, you will get minus cos x plus constant value, and so on. Okay, so there's no reason you don't know how to do or cannot do. And the exponential, the e power something also give you, and b power x dx also give you already. Okay. The first skill in the integration, if you need to integrate two functions, if you need to integrate two functions, and you see this one is a little bit different from the product rules. You see what is the difference? You see on the top of the G there's a 1 comma there. G comma means there's a differentiation function there. Okay. Don't confuse with the previous one that we learned. This is a new equation for today. You see on the top of the G there's a comma there, means there's a differentiation process, means A multiply or A bracket multiply by B, and the B is the differentiation formula. Then you use this equation. So this one is the first function, second function minus integration of gx, and this one f comma. F comma means you differentiate 1 times dx. So it means you need to do multiplication over here by taking gx times the differentiation relationship here. So just take a short note on your personal notes over there. This equation is for combination of normal function and integration function inside integration process. It's a combo operation, meaning inside integration process, inside the integration process, is a combine the normal y and y prime. Take note, and we give a name. This kind of formula is fall under integration by parts procedure. Means you integrate parts by parts. Okay, then you use this formula. Important, I highlight with the red box, means it's an important formula. You write this one in the test, in the correct question, you get 3 marks for this one. So those that I highlight in my slide with the box one is a free bonus mark in the exam. You read the question, you identify the correct equation, you write in the answer sheet, you will get 3 marks in your answer. Like the one that I marked in your quiz 1. You will see that when you write free equation, you'll get marks for that one. Okay, now when you need to use this equation, or you need to use procedure called integration by parts, and under indefinite integral, what I mean by indefinite, you can see the integral don't have limit. The integral don't have limit one. Okay, the far left, the curly integration symbol, you don't have a and b here. You don't have limit here. It fall under indefinite integral. Later, I'll give you one question that have number here. Then you use another formula. This is without the limit. So we solve for the general equation for indefinite integral first. So you let u equal to function f, v equal to function g. So this is the general steps. First, you let u equal to something, v equal to something. So you look at the question. Then you define this one as u, this one is v. Means you look at the question, you write this one out in the answer sheet. Then the next line you write u equal to function f, v equal to function v. Next, you do differentiation for function. After you write u equal to something, v equal to something, you write du equal to function, comma, means you differentiate the function, and dx. You do the same for the v component. dv equal to g comma means you differentiate gx dx. Okay, how do you get this equation? How do you get g comma? G comma means du dx, right? If your v equal to gx, you differentiate gx. Another form of writing, you write dv dx, right? You pull the dx below there to the right hand side, you get this one. Same with this equation. I explain. How do you get this line? Just the normal differentiation. You write v equal to gx, you differentiate gx. How do you represent in mathematics steps? You write g comma, right? When you differentiate. So g comma, what does it mean? It means du dx. You just move the dx from bottom here, dv dx. You move the dx to the right hand side, you get this one. Okay. Next, you integrate. This one you expect already. You integrate u dv equal to uv minus integrate of v du by using substitution all this relationship inside here. Okay. If you compare side by side, it's the same form, but you need to remember how to use this one. Okay. So basically, this one is equal to this one. It depends which one you want to remember. Okay. You either remember this one or this one. Same thing. They are same thing. Only this one look a little bit longer. This one a little bit shorter. But they fall under integration by parts under category indefinite integer. Let's look at one example. So example 17, it asks you to find integration of sine x sine x dx. So basically, within the curly symbol of integration, you see there's a two function there, right? X and sine x. There's a multiplication of x times sine x. So each one of these, you can see that as fx and gx. So what do? You write the formula, compare side by side. You look at the question. You look at the general formula here. Okay. Okay, how this one come out in the exam? I will ask you to differentiate this one using what method? For example, solve this question using integral by parts. Use integral by parts. Yeah. Okay. Question something like this in the test or final exam. Solve this question or solve this function with integration by parts. Meaning I expect you to pull this equation from here and put in your answer. So this is the first line we expect from the question. So again, in test or final exam, I will help you with the keyword, which information that you should use. For example, if you need to use this formula in the test or final exam, you will see I will be using integration by parts. Solve this with integration by parts procedure. Then you use this formula. You put this formula side by side. Okay, first question. On the left-hand side and the question. Edmund, what is your fx? If you compare side by side, what is your fx?
S.
Okay, what is your g comma x?
Sin X.
Okay, sine x, not sin, sine x. Okay, so this is a question that I asked Edmund just now. So what you do is because you already know what is your fx and g prime, so you need to find what is your fx, gx, and f prime. So you know your fx is x, so you differentiate to get this one. Because in this equation, you need to use this one. F comma x means it's a differentiate. So Shakil, what do you get if you differentiate x? Shakil? What do you get if you differentiate x? Calling Shakil. What is the answer when you differentiate x?
1.
Okay, 1. So you write f comma x equal 1. Then you know just now from Edmund answer, g comma x equal to sine x. How you get gx? How you get back the gs? You integrate. Because the comma, you want to remove the comma, get back the original one, you do integration. So I'll already tell you there's a table to refer when you integrate something or differentiate something. So I will not repeat that one. So all what you need to do is understand the concept and the way we solve question. So you compare side by side with integration by parts method. Fx already solve your fx and f comma. From the question, you compare side by side, g comma x sine x, you need to get what is gx, right? How you get from g comma to gx, you use integration. So you integrate sine x, you get negative cos x. Again, be careful on the negative. This is a very popular mistake also. When you integrate, remember, always check whether there is a positive or negative sign. Okay. Next, again, this is just to show you that there's a table that I showed you just now. So there's no reason you don't know how to do this one. You don't know how to do this one. So back to the question and look at the standard equation. What do? You just substitute accordingly. So the first one, you compare side by side, you copy the question, put to the left hand side. Then you just substitute. What is fx? Fx is x. What is gx? Gx is minus cos x. This one to this one. Next, continue with this one, substitution. Integration. Gx, what is gx? Negative cos x. Again, remember to use bracket to help you to save some marks. Because students always forget negative sign. So I will recommend always use bracket. Then copy what is your gx inside here to save your negative sign. Then what is your f comma x? 1. You just substitute this one and this one in here. Dx. The rest is just normal solving mathematics problems. This one become this one. Remember there's a negative sign there. This one, I will solve the positive sign first, or positive negative sign first. I will pull the negative sign out, I will get positive. I change my negative sign to positive. This one later I process. I solve the positive negative sign first. After that, I solve this one. Integrate this one, refer to the table. If you really forget, there's a table for you. So the final answer is minus x cos x, this one. This one refer to this one. Let me see. It is cos, so it's this one. Okay, so you refer to this one equal to sine s plus c. We just copy the whole answer into here. Basically, you don't need to memorize. There is a table for you to refer. Okay, your job is to rearrange the equation. Look at the table, give me the answer. Why there's a c there? Why is the c there? Because your integration don't have limit. If your integration have limit, then you can remove the c. But if your question that you get in the test without the limit in the question, you always need to give me the plus c in your answer. Any questions so far in example 17?
No question, sir.
Good, huh? Okay. Let's look at one more example. Okay. So example 18, evaluate this one. Or solve this one. Solve integration of ln x dx. Okay. So I'm showing you another method. Same formula, but I use the UDV or equation. So, right, if you use this equation, you compare to the question. So you compare side by side, you know that your integration ln x equal to u dv, right? So you know that your u is ln x, dv is dx. So you differentiate u equal to ln x, you differentiate ln x, you will get du, you du dx ln x, you will get 1 over x, right? So you rewrite the equation, du over dx equal to 1 over x. You rewrite in the linear form, you move your dx to the right hand side. That's why you get du equal 1 over x dx. Again, if you don't know how to differentiate, there's a table for you to refer. Okay. Next, you compare side by side, dx equal to du. Dx to du, how do you get your u and x? You integrate. You integrate both sides. On the left hand side, you get v. On the right hand side, you get x. Okay. Again, there's a table for you to refer. Next step, you just put in the value using the general equation. You copy the question, then use the red color equation. So copy the question, use the red color, substitution all this value inside there, rearrange. If need, use table to help you. So the first one is uv. What is your u? Ln x. What is your v? X. You get this one. Minus integration u du, just copy. Integration x, 1 over x dx. You just substitute only. Your job is just substitute. Then the next steps, polish up your answer. This one become this one. Remove the bracket. This one, simplify. Cancel x, you get 1. Integration 1 dx, refer to this table, which is this one. Copy this one inside here. You get x ln x minus x plus c. Again, if you see there's no limit of integration, there's no limit, there's no number here, remember to give me c. Okay. Example 19, I will take you, I will give you as a homework. You go and see, all the answer is there. So I'm going to flip this one. Same procedure. Okay. Okay. This one is a homework also. Initially, I want to make this one as a quiz, but I will give you this one as a homework. Same procedure, and this is the final answer for example 20. Okay, there will be one quiz. There will be one quiz tomorrow about integration. Just prepare. So don't miss tomorrow class. I give you hints already. There will be one quiz from integration. Example 21, also your homework. I give you a table. Initially, also I intend to make this one as your quiz, but I will just let you go, and this is the answer for this question. Okay. Same procedure. Okay. Let me go a little bit more. Maybe 2 or 3 more slides, then we call it a day. Okay. Now, this is, apologize for this one. Ignore the white color, this one. This is the one that I mentioned. Same equation, but now you are having the finite integral. This is under finite integral. If your integration here don't have number, then it fall under indefinite. If you're seeing the question having number, then it fall under defined, but it's still using integration by parts methods. Same procedure, only now you need to add in the substitute the numbers inside there, and inside here later there will no constant value C in your answer. Okay, so this part only substitution, and you need to be careful on the substitution of number. Okay, the rest is still same. Then I highlight the limit, and I highlight this one is important, and this formula will be useful when you integrate, have a limit one, then you use this one. Okay, this method fall under integration by parts methods or procedure with finite integrals. Okay, the just now example, or you don't have the a and b number on top and bottom of the integral. So if you see there's a number inside the integral, you use this one. Same procedure. All these are same, only you substitute the number inside there. Let's give you an example, right? Now, you see there's a different compared to the previous example. When you see integration sign, there's a number below and top. It means this fall under defined integrals, and you can use integration by parts and use this general equation. So if you see this one, you quickly copy this equation and put in your answer. You get 1 mark for this equation. Okay. If you understand the previous procedure, this is just application of what you see just now, and substitute the A and B inside your answer, and you get the answer. Again, I pull the table to refer. There's always a table for you to help you. So it's important for your quiz, incoming quiz. So yeah. Okay, then you just copy. You can either use this one or this one, same. They are same formula. It depends on which one you are more familiar. If you use U, V, then you need to do the procedure where you use U equal what, V equal what, then you do du dv, then you get something. Then you integrate dv, you get U, something like that. So you compare side by side. Your U, I'm using this second equation. So if you compare side by side, you know that your U is tangent minus 1x. Then you differentiate, you get du dx. Again, there's a table. There's a table to refer just now. Which table to refer to? Because in this question, you only see x, right? So you use the table that d over dx trigonometry equation, and the answer is x. You use this table. If you see there's something e there, then you use another table. This one is x, so you use this one. Okay, so you need to differentiate 10 minus x. You use this one. Sorry, this one. Okay. So du dx equal to this one. You move your dx below there from the left hand side to right hand side. You get this one. You do the same for dv. You put side by side. Dx equal to dv. You integrate, you get u equal x. The next step is just substitution like just now. Use this formula to help you. Use this derivation, substitute accordingly. You'll get this one. Copy the question again. Refer to this equation to solve. So the first one, uv substitution of AB answer. How you do? U. Okay, U. Okay, this one. Okay, your u is 10x, right? V is x, right? So basically your time, it's a multiplication. You take this one, u times v, right? So you get 10 minus 1 bracket times x. Basically, you rearrange, you get x 10 minus x, and you copy the symbol of this one. Means later you need to substitute the value of b and a. So what is your b and a? You refer to the general equation and the question. Your a is 0, b is 1. So you just substitute accordingly. B and A. You just compare and then you substitute. Nothing hard here. Okay. Then the next step, also do the same. You copy A, B. So you compare side by side. What is your A and B? All right. Your A is 0. B is 1. What is your V? V is X. What is your du? Is this one. Copy here. Basically, just substitution. There's nothing complex here. Okay. From these steps onwards, normal mathematics procedure, and this one just substitution. Normal integration substitution means you take 1, substitute in x, substitute in 10x1 minus 0. Okay, 0x 10 minus 1, 0. Okay, so you'll get the first one. You substitute 1 inside the equation. 1, 10 minus 1, 1. That's why you get the first one. Minus the 0 component. So 0, x becomes 0. 10 minus 1, x also 0. You get this one. Any question from here to here? Edmund, you okay? From here to here.
Yes, sir.
Okay, Shakir, you okay? This one to this one.
Yeah, okay, sir.
Okay, Nizam, you okay? Nizam, you alright?
Yeah, get it.
Okay. Next, I just copy this one because I solved the front first. Then I slowly solve the second one. Back to the new slides. You know that 1 tangent minus 1 is 90 degree. So just take note on that. 1 minus 1, 1 inverse tangent 1, 1. The value of that one is pi divided by 4. Again, when you deal with trigonometry, you deal with radian in pi. Then this one 0. 0 multiply something, get 0. Copy this one, continue to solve. Okay. And before I substitute, I focus on this one first. Then I substitute back the answer. Now this section only focus on this one. So I pull my x up, I get x divided by 1 over x squared dx. And remember to copy the limit 0 to 1. So this basically is a normal integration with the top and bottom, means u divided by v procedure. So normal one you use u and v, but this one I just change a little bit. I use t to represent this one. So t equal to 1 plus x, or normal one you more familiar is v, u divided by v, same procedure. I use t here. And dt dx, I will get 2x. Okay, I rewrite the equation. I pull the 2 to one side, dx to one side, I get this one. This 2 is the same, only I rearrange the equation. 2 I pull to the left, I get half. Okay, because it's divide. This one is multiplication. I pull to the left, I flip the operation. This one move to the left, I get half. Dx, I move to the right, I get x dx. Then I compare side by side. So I rewrite in term of t, or you can write in term of u if you want. So the first one I can write as 1 over t, because your t is 1 over x squared. So 1 over t times dx. What is your x dx? X dx equal to half dt. So you get this one. You pull your half outside the integration. You only have 1 over t dt. And you know that you have a 1 over t just now. If you really don't understand, or you don't know what is integration of 1 over t, refer to the table, you'll get ln. You get ln t, and remember to put the double goalpost. Make sure that you always get a positive value here, and then you change the integration sign to straight line or half of the bracket also can, and from 1 to 0. What I mean by this, it means you substitute 1 inside here minus 0 inside here. Okay, it means, yeah, half. Is it correct? Half. I think there's a substitution wrong here. All right, it should be 1 and 0. Okay, it should be 1 and 0. There's a substitution error here. Okay, there's an error in my slides. Okay, so basically you substitute 1 here, 0 here. So there's a substitution error in my slides, yeah? So why there's a 2? Ln 1. The limit is 1. So again, there's an error here. There's an error here. So we need to check this one. Huh? Right, those are watching YouTube, there's an error from here to these steps. Okay, substitution error here. It should be 1 and 0 here, not 2, 1. Huh? Okay. So once you get the substitution, you substitute back to here, and then you complete the calculation. Okay, you complete the calculation. Again, there's a substitution error in my slides. Huh? This procedure, I believe, is wrong, because if you follow along, this one is 1 and 0. It should not be 2 and 1. Okay, it should be 1 and 0. Okay. Tomorrow we will look at reduction formula, and just stand by. Tomorrow I might give you a quiz. Okay, just stand by. Huh? And the quiz will be on integration procedure. Okay, so later I will upload the slides on the Moodle. Okay, with this I end the recording.